Hi guys, we're going to talk about finding volume of prisms, pyramids, and cones today. To start off, I want you to take a look at this picture. How many gumballs do you think are in the container? Put a number for me. How many gumballs do you think are in this container? And then tell me, why did you pick that number? Okay, hopefully you've got your guess here. So I'm going to give you some new information. Let's say that the jar is 8 centimeters long. So it's going to be 8 centimeters long and 8 centimeters wide and 10 centimeters tall. Each gumball is going to be 1.5 centimeters wide. How does this information change your guess? Do you keep your guess the same or do you change it? Hopefully it helps you change your guess because now we know what the dimensions are. Okay. Now we can find how much the container will hold. In figuring out how much the container will hold, guys, that's volume. Volume of a 3D figure is the number of cubic units needed to fill the space inside that shape. How many of these little 1 by 1 by 1 blocks fit inside a shape, whether it's a gumball container or if it is a bathroom floor? How many cubic units fit inside? So volume is how much a container will hold. And again, we're talking the inside. How much will fit inside a container, whether that's a prism, a cone, a cylinder, a pyramid, a sphere, how much fits inside. So our first example, here's our box. Okay, so here is my length. Here is my width. Here is my height. Okay. If we look at the first picture, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so looking at it, we just filled in 10 blocks. Okay, going this way, we did 1, 2, 3, 4. So what we just did here was we found the base area. We did length times width, okay, length multiplied, by width, length was 10, width was 4. There are 40 little cubic units inside here. But then we took our 40 and we multiplied it by our height. We took our base area times our height. So we did 40 times 3 to get volume to be 120 centimeters cubed. Anytime we're talking about volume, we're going to take the base area and we're going to multiply it by our height. Let's use this on the gumball problem and see what we end up with. See if your guess was close. So our volume formula, we are going to do BH, which is going to be the base area times the height, no matter what the shape is. Okay, what's the base area, multiply it by the height. So using this new information, we're going to calculate and figure out how many gumballs fit in the container. Okay, think back. So we said that this was 8. We said this went back 8. And we said this was 10. So if I do my base area, that's going to be 8 times 8, which is 64. And I'm going to do my base area times height. So 64 times 10 is going to be 640 centimeters cubed for the container. Okay, 640 centimeters cubed for the container. Our container, though, it's not empty. Within the container, we have 1.5 centimeter gumballs. So what I'm going to do is I'm going to do 640 divided by my gumball width, which is going to be 1.5. And this is where, guys, you might want to go ahead and pull up Desmos. So I'm going to do that here as well. I'm going to try to do that here as well. Okay. So if you go back to Schoology and we go to our class, okay, Desmos calculator, if you're not there yet, let's go ahead and get there. And so our note said we were going to do 640 divided by 1.5. This is approximately how many gumballs are going to be in that container. Okay, kind of split my screen so that way you guys can see both, hopefully. Okay. So we took how big the container was, divided it by how many gumballs there were. We're looking at about 427 gumballs in the container. If you guessed around that number at the beginning, awesome, nice job. What we're going to focus on is we're just going to focus on 3 different shapes. We're going to focus on rectangular prisms. We're going to focus on square pyramids, and we're going to focus on cones. There are going to be some formulas that I'm going to give you. We're going to work them out. There are going to be 3 down here that I want you to try, and then 3 on a different paper that I will have you try and then turn in for me to look at. So our first problem, volume of a rectangular prism is length, width, height. Everything is getting multiplied. So Mr. Westcott's building a craft box. What is the volume of the craft box in cubic inches? So here is my length. Here is my width. Here is my height. Volume is going to be length multiplied by width multiplied by height. We type this into Desmos. We've got 4 times 3 times 5 gives us 60. So my volume, Mr. Westcott's Craft Box, volume equals 60 inches cubed. Okay. Square pyramid, the formula that we are going to use. So you might see it as base times height divided by 3. Or you might see it as 1/3 base times height. Same thing. I just want to make sure that you guys see it as both. So remember B, okay? B equals the base area. And so my base in the picture, it says that is 7 and 11. Okay, this is going to be my base. So base area is going to be 7 times 11, which is going to equal 77. Okay, big B is base area. Area, we do length times width. So we need base, we found it. H is going to be 8 for my height and then divide by 3. So my volume is going to equal 77 times 8 divide by 3. Coming back over here to Desmos. So 77 multiplied by 8. And then we're going to divide, all of that. So that's not going to work. Okay, so I'm going to go back and put this in parentheses. All of this is going to get divided by 3. And we end up with volume being approximately 205.3 centimeters cubed. Okay, we're using the formula and just substituting the numbers into it. My last shape is going to be a cone. My formula for this one is 1/3 pi r squared, where r is going to be the radius, which remember goes halfway across the circle. So determine the volume of a snow cone holder with a radius of 4 and a height of 6. So this is going to be 4. This is going to be 6. Here is my radius. Here is my height. Volume equals 1/3 pi r, we said was 4 squared. Oh, my fault, guys. There should be an h here. Okay, this is just part of the formula. And then h we said was 6. And so I'm going to go back to Desmos and I'm going to type this in 1/3. Notice I've got to hit the arrow button over. Okay, after I type my 3, if I start typing, it's with the 3. We don't want that. So make sure you hit that arrow button over. There is a pi symbol. So 1/3 pi 4 squared times 6 is going to be 100.53 inches cubed. What I would recommend doing is pausing this video, trying these 3 on your own, and then playing it and seeing if we match up on answers. Hopefully you actually tried these out. So first one, length times width times height, 6 times 6 times 6 gets me 216 centimeters cubed for our volume. That's how many boxes fit inside. My next one is a cone, 1/3 pi r squared h. H is going to be my height, is going to be 9. R is going to be 6 because we only want half of the circle. Okay, remember that when we talked about radius earlier, radius was only half the circle versus 12 is the entire circle. So making sure that you're watching out for that trick. I typed it into Desmos, got about 339 centimeters cubed. Last one, my square pyramid. Here is my formula, base area times the height. My base area is 8 by 8. So 8 times 8 is 64. 9 is my height. all divided by 3. You can see over here is typed in at decimals. We end up with 192 centimeters cubed.